Hey everybody, it's our last week of chemistry, okay? So we've really kind of pared it down to the most essential pieces that will help you for if you're going to take science ever again, right? And we're just talking mostly about acids and bases. So this is the last piece of it. This is a neutralization reaction. So you saw a little bit of in our last video if you watched me do the thing with the pH lab and we mixed together baking soda and vinegar, you would have saw it all kind of fizz together. And in a perfect world, if you neutralize something properly, your acid and your base should mix, and then you're going to end up with a neutral pH when you're done. Okay, so we're going to talk neutralization. We're going to talk about balancing. I'll talk a little about reactants and products, and we're good to go. So neutralization reaction. Okay, this is basically it. You have a reaction between an acid and a base, and it will produce a salt and water. So acid, remember that was things like hydrochloric acid, HCl, stuff like that. Base, NaOH, other stuff. So we saw that in last week's activity, you were kind of exploring your house for things that were acids and things that were bases, and you could use red cabbage to do that. You could use a pH indicator to discover what sorts of things are acids and what sorts of things are bases. Okay, so when you mix them together, you take an acid and a base, you should end up with water. Okay, so you'll end up with something kind of neutral, and you'll end up with a salt. So by salt, we could mean this, KCl, right? We could mean table salt, like NaCl, right? But the idea is you have some kind of acid, you have a base, you make a salt and water. If you see these, by the way, if you're ever looking online and you're like, what is this? AQ means aqueous. It just means you've dissolved it in water. So here we have an acid that's in water. Here we have a base that's in water. You end up with a salt that's also in water. And you have water, which we don't call aqueous because that would be crazy because you can't have water in water. So we just call it L. So we say it's a liquid, right? So hydrochloric acid is in water. This is potassium hydroxide, it's in water, and this is potassium chloride, it's in water. So you don't have to name all these, by the way. This is HCl, is fine. You could say KOH, it's fine. KCl, okay? So aqueous just means it's in water, and then obviously for water, it's liquid, so we leave it like that. Okay, so neutralization. Acid is anything that's corrosive because it has a pH below 7. Base is anything that's corrosive, it has a pH above 7. And when you take a base and you add it to an acid, it should result in something that's no longer corrosive and has a neutral pH. Okay, so when you take acids and bases, mix them together, you should be able to create something that's been neutralized or is now neutral. Okay, so take a look at one of the easiest examples. So the way I say this example is easy is because you have one of everything. Okay, this is very easy to balance in the sense that you have one of this compound, one of this, and you're creating over here, these are called your products. You're creating two products over here. So we have Na, and then we have NO3. So this is your salt, and then this is your water that you're producing. Okay, so acid, base, salt, water. Okay, it's simple, one of each, because you notice here there's one hydrogen, here there is one OH group, so it makes sense that this hydrogen, this OH group, will combine together into this water molecule. So water is HOH, so this is the water over here. This NO3, this Na, those combine together here into NaO3, and that's your salt. Okay, so this is probably really straightforward neutralization because it's very simple to understand that one of this, one acid, one base is going to make one salt and one water. Okay? So we would only know that we've successfully made something neutral if we used a pH indicator at the end. So that would be the red cabbage juice that we had last week. And you could use that to check, did I make it neutral? Okay, so let's take a look at your activity that you're going to try this week. I'll help you with the first few, and then I want you to try some on your own. So this is just a neutralization worksheet. So you're going to try to balance equations to understand if they've been neutralized or what a neutralization reaction looks like. So the easiest way to do this is to think about how many hydrogens you have and how many OH you have. So here we're trying to take HCl, we're adding it to our base, which is NaOH, and we're making water and salt. Okay, so basically we have one chlorine over here, one chlorine over here, that looks good. We have one H here, one H here, that's good. We have an OH, we have OH, we have one Na, one Na. So this first example is actually pretty straightforward. It's just one of each. And if you counted everything, so we have one Na, we have one Na, so that's good. Our sodiums are perfect. We can check the OH. Here I have a single OH, here I have a single OH, so we're happy. Okay, check your chlorines. Here I have one chlorine, here I have one chlorine, so I'm happy. And then here I have an H, and here I have an H. So those match as well, so I'm good. So I know I've balanced it properly. I'll show you another example that doesn't quite go as easily as this. So we'll kind of jump around, but say, for example, this question. Here it says H2. You look here, it just says a single H, right? So in this first example, it was very easy to understand that for this H, it linked up perfectly with that H. This OH linked up perfectly with this OH, right? It was one and one. It was very straightforward. For this next question, it's not quite like that. We have here H2. So here there's only a single H, so I'm going to need two of these. Okay, so now I have two of these H's. And over here, this says OH, and it says that there's two of them. That's actually really helpful, because if I think about these OHs here, I've put a 2 here, so I've successfully made the OH match the OH. I've successfully made the H match the H over here. Okay, because this was H2. Well, great, this is two H's. This says OH, but double it, and this also says OH, double it. Okay, now we're going to check everything else. Check the CO3. This says CO3, so I'm pretty happy. This says SR, this says SR, great. So you only need one of each of everything else. Okay, so basically what they're saying is if you take one of this acid molecule, you take one of this base, you're going to end up making two waters and one salt. Sorry, that's my printer in the background. Okay, if we take a look at a few on the bottom, okay, so that's two examples there. Let's take a look at one on the bottom. So here I've basically shown you another example, but in these examples, I have it as H2O. Okay, so you might notice that water in this first case is written as HOH. I think it's usually easier to balance as HOH because it's easier to count where everything is coming from. So what I'll show you, for example, here, I'll do the first one, and instead of writing H2O, I want you to actually change it to HOH. I think this will actually make it easier to balance. So I'm just going to prove why it makes it so much easier to balance. So here we see that this H, you match it up to here, and you make sure that you have the same amount. So we can see here that yes, I have one H, yes, I have one H, so I'm pretty happy. Then you look at this OH, you match it to that OH, and you realize, okay, great, it's still 1 and 1. So we know that the hydrogens match, that's good, and we know that the OHs match, so that's good. Now check your Na, there's one here, check your NO3, NO3, so everything is 1, and we're super happy, okay? So I say that's really easy to do because for this next question, it can be kind of hard to tell. So for example, it says here, this says H2, and I look over here and I see H2 and I'm like, oh, I think that's good. But then here it says OH, and you look there and there's no OH. So you're like, what do I do, right? That's confusing. So my first suggestion, change this to OH, right? Change this to HOH. It's going to make matching way easier. So we look here, this says H2. Okay, so I'm looking here. That's definitely not two H's, so I'm going to force it to be two H's. I'm going to say 2 because now these two H's match these two H's and I'm much happier. Okay? Because it's balanced, right? You can't just destroy hydrogens in your reaction. They have to go somewhere. So if you have two hydrogens here, that means you need at least two water molecules, right? This is water, so you need at least two. Next, we look here, OH. Here it says OH, but we have two of them. We have twice as many OHs. So I say, okay, well, I'm going to need two of these. I'm going to need two OHs. So now we have an example where OHs match, our hydrogens match. So we're doing okay. We just have to make sure everything else matches. So on this side, I have SO4. On this side, I have SO4, so that's good. Okay. On this side, I have 2Na, and on this side, I have 2Na. So I'm actually pretty happy. I just put ones everywhere else. So this is an example where for one acid and two bases, you're making two waters and one salt. Okay, so it'll take you a little bit of practice. Try out this worksheet, play around with the balancing, try to match them all up. You should be able to sort of fill this out online. So I've given you at least 4 out of the 10, not too shabby. So try that out online. Oh, sorry, there's 11. Anyways, I did 4 out of the 11. That's fine. And then I want you to do a little bit of research on your own and see if you can figure out some examples of what do we even use neutralization reactions for, right? So you can come up with any examples on your own. You could think about at home, why would you do neutralization reactions? You could think about in terms of lab safety, why you would need to do neutralization reactions, or why this would be helpful in a lab if there was a spill on the floor. What would you do, right? So you could think about that, or you can just research some. So just research like, hey, I don't know, does it make toothpaste? Like, I don't know. What does this have to do with anything? Okay, so just find some examples of neutralization. What does it even do? Does it help us make products? Does it help us make stuff safer? Like, what do we do with this knowledge? Great, we have neutralization, acid plus base makes a salt and water, but how is that useful to us? Okay, so that's all you're going to try this week, and then chemistry is done. And we're going to move on to something new next week. Okay, thanks everyone, and good luck.